All right, so this first question here, we're just kind of setting this up. We're not going to solve it. So it says, find the average of 3 test scores if the first 2 scores on that, and then we have the third one as a variable. So we know for average, we're just going to add these all up and divide by 3. And so I'm just going to do 74 plus 92 plus S, and then all divided by 3. It's done. All right, so number 2 and number 3 kind of similar here, and so I'll go ahead and do number 3. So it says the sum of the squares of 2 consecutive integers, where n is the first of the 2. So sum, of course, means we're going to be adding these 2 together. And then it says, let's see, the sum of the squares. So n is the first one, so obviously that's going to be n squared. And then the next one, if the first number is n, the next one is going to be n plus 1. And so I need to square that as well. So you can expand that if you want, or I think you can just leave the answer like this. All right, next up here, number 4. So for this one, it says the rental company charges $80 a day, 25 cents a mile. Rent it for 3 days. The bill is $331. So I know that $331 is my bill, and that is going to equal, and then I know I have 20 cents a mile. Now, since that's cents, I'm going to put it as 0.25 M. And then $80 a day. So you could put 80D, but I know that the days is 3, so I'm not going to use a variable for that. I'm just going to plug in the 3. So 80 times 3 there. So now I just solved that for M. I'll let you guys do that on your own. All right, next up here, it says that we've taken 3 tests so far, and we're going to take one more, but the last one counts double, and I want my average score to be 80. So I know average here, I'm going to make a big fraction, and I want that average to equal 80. Now I know my first 3 tests, I got these ones, so I'll just put that into my fraction. And then my last one here, I would put x there, except it says it counted twice, so I'm actually going to put 2x since it's kind of double there. And then I also need to put a 5 down there because if you kind of think about it, if we're counting that as 2 tests, then we're going to have to divide by 5. Otherwise, our score would kind of skyrocket here by doubling that number. And so since we're kind of counting that test twice, we need to divide this by 5. All right, next up here, it says that Phyllis invests $11,000 total into these 2 accounts. And so my first equation I would set up here is x plus y equals 11,000. I don't know how much she invested in each, but I know that totaled 11,000. And then my next equation, I know that the money gained was $786.25, and that was based on the first account getting a what I'm going to consider a 0.0725% return, because the 25 is going to be the quarter. And so I'm going to call it 0.0725x plus 0.07y. So now we have a system of equations here, and so I'm going to set this up with elimination. I'm going to go ahead and use negative 0.07 just because it looks like a little bit easier number to work with. I definitely can use a calculator for this. So this will be negative 0.07x minus 0.07y equals, we got 11,000 times 0.07, so that'll be negative 770. We'll go ahead and add these down. So these cancel. I get 0.0025x equals 786.25 minus 770 is 16.25. So now we'll divide those by 0.0025. Got to be careful with your decimals here as you're typing all this in. And so I get that this one is 6,500. So my first account here, which is the 7.25%, is going to be 6,500. And then since they add up to 11,000, I can subtract that from 11,000, and that'll give me 4,500. All right, next up we got number 7 here. And so this one's a little bit different. It says Ben invests $3,000 at 4% per year. So I kind of already know that that's 3,000 times 0.04, since I know what that value is. On the previous one, I didn't know what each individual one was. And then so how much additional money must he invest at that one? So I'm going to say now I don't know that, but I know it's at 0.055 because I'm going to see this as 5.5%. And then we want to end up with 4.5% total return. So what that one's going to be is actually my amount invested is going to be 3,000 plus x, and then I'm going to multiply that by 0.045. because you have to kind of consider here that these two are going to add up to give me my total amount invested, and then my percentage rate is going to be in there. So I would just solve this now. It's not even a system because we only have one variable and one equation. So this would be 120 plus 0.055x equals, and then I would go ahead and distribute that in there. So 3,000 times 0.045 now is going to be 135 plus 0.045x. And so we'll get the, let's go ahead and move the x's over to this side. I'll move the 120 over to that side. And we get 0.01x equals 15. And so that'll be, I think, 1,500, but we'll just check it in the calculator to be sure. Yep, so x is 1,500. All right, next up here, it says a woman earns 11% more than her husband, and then together they make 66,465. So I would just say, like, husband plus wife will be 66,465. And then my other equation is based on the fact that the woman makes 11% more. And so I'm going to compare the husband and the wife here. And I would have to multiply the husband's, salary by 1.11 in order to get to the wife's. So you can kind of visualize it here. If the husband made $100, the wife would be making $111, which is what I want with that setup there. Okay, so then I'll let you guys solve this from here. I would just use substitution, where I would plug that in right there since it's the W, combine like terms, and then just solve it. All right, next up, we got another little riddle here. And so it says, 2 years ago, I was 9 times as old as my daughter. Okay, so we have kind of a, let's see, it doesn't say if it's the father or the mother, does it? Okay, so I'll go ahead and call, I guess, them M for movie star. So the movie star, and it says 2 years ago. So I'm going to compare the movie star and the daughter, but I'm going to compare them both 2 years ago. So I'm going to subtract 2 from their age. And it says I was 9 times as old as my daughter. Now we have to actually multiply the daughter's age by 9 to get to the movie star. Then my next equation, it says now I'm 7 years older. Sorry, not 7 years, 7 times as old. So 7 times the daughter is going to equal the movie star now. On that one, I'm not adding or subtracting anything to their ages because it's the present day. So we can use substitution for this. So I can take that and substitute it right there. I'll go ahead and distribute that as well. So that becomes 9d minus 18 equals 7d minus 2. And then I'll subtract 7d, and I'll add 18. So that would say that 2d equals, let's see, 16, and d equals 8. And so that means the daughter is 8 now. However, the question is, how old is the movie star? And so the movie star is going to be 7 times as old as the daughter, so 7 times 8, so she'll be 56. So make sure you're actually typing in the age of the movie star, not the daughter. All right, next up we have a couple similar questions here. I'm going to go ahead and do number 11. So for this one, it says we have $3 in nickels, dimes, and quarters. So I can already set up here, since that has to do with money, I would say 5n plus 10d plus 25q equals 300. So I'm saying that the value of the cents equals 300 cents. And then next up it says she has twice as many dimes as quarters. So I'm going to compare the dimes and the quarters. She has twice as many dimes, which means I have to multiply the quarters by 2 to get to the dimes. And then the last one here, 27 more nickels than dimes. So let's see, let's compare the nickels and the dimes now. And she has, what does she have? 27 more nickels. So she would have to add 27 to the dimes in order to get to the nickels. Okay, great. So now what I would do is I'd probably use substitution for this. And so let's see, I can get rid of, what can I get rid of? Let's see, I'm actually going to do this. I'm going to take this equation, I'm going to divide this, actually I'm going to multiply this by 1/2. And so I'm going to say 1/2 d equals q. And the reason I want to do that is that'll allow me to get everything in terms of d. So I'll go ahead and write that down here, 1/2 d equals q. So now I can rewrite this as 5 times 27 plus d, since I'm doing my substitution for n, I can do 10D, and then I can do 25 times 1/2 D, and then that's going to equal 300. So I'll go ahead and kind of distribute here. So 27 times 5, that gives me 135 plus 5D plus 10D plus, and I'll call this 12.5D equals 300. I'll go ahead and subtract 135 over, and I'll combine like terms. So that's 300 minus 135 is going to give me 165 equals 15 plus 12.5 is going to give me 27.5D, and then we'll divide by 27.5. And that tells me that D equals 6. So I have 6 dimes, and then I can just start plugging that back in to find the nickels and quarters. All right, next up here it says we got a square parking lot, and then it says that it has a building that's 80 by 60 in one corner, so I'll draw that there. And then it says the rest of it's the parking lot, and that the area of the parking lot is 12,100. So what are the dimensions of the entire plot of land? Okay, so it is a square, so I'm gonna make this X and X, all right? And so what I'm gonna say here is that, let's see. Well, I'm gonna make an area formula. So area I know is just length times width. So I know on this one it's X times X, or X squared. And the area here, I actually know it's going to be 12,100 plus 60 times 80. Because the 12,100 is just for this piece, like the L in there, and then the area in here is obviously in this space is 60 times 80. So I know that those two must add up to give me X squared. So now I'm just going to solve this. So I'm just going to type the whole left side in my calculator here. Plus 60 times 80, that's going to give me 16,900, and we'll just square root that. And so that must mean, that looks like something to do with 13 there. So that's, yep, 130. Technically it's going to be plus or minus, but because this is kind of dimensions here, I'm going to say it's 130 feet by 130 feet. All right, next up here we have a rectangular lot. So we got to draw a rectangle now. This is 8 feet longer than it is wide. So I'm going to call this X. I'm going to call this X plus 8. And it says the area here is 308. And so we're going to say 308 equals the length times the width. And this looks like a quadratic here. So I'm actually going to subtract the 308 over. And so there you go. All right, we're going to go ahead and factor this. So we're going to multiply to multiply to 308 and add to 8. So what does 308 divide by? Well, we got 2 and 154, obviously not going to work. It does not divide by 3, so I'll try 4. 4 and 77, not really even close, so 308. 5 obviously not going to work. I know 6 doesn't work because 3 didn't work. Let's try 7. 7 and 44, I'm getting closer here. 308 divided by, let's try 11. 11 and 28, still not there. So maybe 14. Let's try 14 since 2 and 7 both worked. 14 and 22, there we go, got it. So we got 14, we got 22 with a negative 14, so we'll say X minus 14 and X plus 22. So X equals 14, X equals negative 22. Obviously the negative answer doesn't really make sense here, so I'm going to say X equals 14. So that one's 14, and then this one's actually 22 if you think about X plus 8. And then which one was longer? It was 8 feet longer, so the length is going to be the 22, and then the width is going to be the 14. So you do have to kind of go back and read that question. All right, next up here, number 15. So it says that the perimeter here will be 200 feet of fence, and then the length and width of the, okay, find the length and the width if the area is 475. Okay, so I'm going to label, I'll go ahead and redraw this as a rectangle here. So I'm going to label this one X and that one Y. So I know that the area, which is X times Y, should equal 2475. And then I know the perimeter, which perimeter is 2L plus 2W. So I'm going to say 2x plus 2y is going to equal 200. So then what we're going to do is I'm going to isolate either x or y over here. I'll go ahead and isolate y. So I'm going to say 2y equals 200 minus 2x. And then we'll divide everything by 2. So 100 minus x equals y. And so now I can use that to substitute in here for y. So 2475 equals x times 100 minus x. And so then I will go ahead and distribute that. So that's 100x minus x squared equals 2475. I'm going to go ahead and factor this since it's a quadratic, but I like my square to be positive, so I'm going to move it over here. So plus x squared minus 100x. And so I get x squared minus 100x plus 2475 equals 0. And so now we're going to factor this. We're going to try to multiply it at 2475 and add to negative 100. So let's break down 2475. Let's go. 2475. Let's try 5. 5 and 495. Not really that close there. Since this is ending in a 5 here, I'm going to try everything. I'm going to try like 15 next. That doesn't actually work. So let me go away from that. Let's try 25 then. 475 divided by 15. Oh, actually 15 does work. It's 165. So it does divide, but it doesn't add up to 100. So I'll bet 75 will work because we're getting really close here. Or sorry, not 75, 25. 25 is 99. No, that doesn't work. Oh, because you need to add up. Okay, let's try 35. I'll bet 35 will work. No, it does not. Shouldn't have bet. 45 and 55. There we go. Not 44. 45 and 55. Okay, so we're going to make those both negative. And so x minus 45, x minus 55 is going to equal 0. So x could equal 45 or 55, which just means one of these dimensions is 45, one of them is 55, whatever one you want to call x and whichever one you want to call y, it doesn't matter. And so the larger dimension, of course, for me is 55, and the smaller one will be 45. All right, next up here, you can see they gave you the dimensions of the mat here, and they say there's a little extra x on each side. They say the perimeter of the whole mat is 210, and so that's kind of like the big rectangle on the outside. And so if you think about the dimensions here, this one is going to be x plus 15 plus x, and so I would simplify that into 2x plus 15. And then same idea here. This one is just x plus 20 plus another x over here, so that's going to be 2x plus 20. So my perimeter I know is 2L plus 2W, and so I know I want that to be 210. And then I know that this is going to be 2x plus 15 on one side, and then 2x plus 20 on the other. This looks like it's not a quadratic, so you should not need a factor. You can just solve it. It's a linear equation. All right, here they're giving me the perimeter of, no, they're not giving me any perimeter, but they gave me the dimensions of the printed area, and they said the perimeter of the whole thing is 1.5 times the perimeter of the printed area. So I would actually just find the perimeter of the printed area first. I'll kind of label it like that. And so since I know the dimensions, I know it's just 2L plus 2W. So I can already figure this out. It's not going to be my final answer, but it's going to help me get it. So 200 plus 280, of course, 480. Okay. And so then they say that the perimeter of the poster is just going to be 1.5 times that. So I already know that. So that's great. So that's going to be 720. Okay, so now I can say 720 equals 2L plus 2W. And once again here, I would say that my length is, depending on what you call your length, so I'll go this way. It's x plus 140 plus another x, so that's 2x plus 140. And then plus... And if I go the other direction, same idea, it's going to be 2x plus 100. So now again, just solve that. All right, next up here we have this question where we have 75% antifreeze and 25% water in the radiator, and we want to make it 50% antifreeze. So, and we know that the capacity is 3.3 liters, so we're gonna have to drain some antifreeze, or drain some of like our combination here and replace it with water to make that even. So how much do we have to do? So the way I would think about this, I would just think about this in terms of the antifreeze. So right now, 75% of our 3.3 liters is antifreeze, and I'm going to take out some of this kind of whatever right now is in my car. So right now I'm taking out this 75% solution, and I don't know how much I'm going to take out. That's the answer to our question, but I know that whatever I'm taking out should be a 75% because that's what I have in my car right now. And after I do that, I want there to be 50% antifreeze out of my whole 3.3 liters. So that's kind of how I visualize that one. And from there, it's actually a really easy solve, so I'll let you guys take it from there. All right, next up here, we need to solve this one. And so what we'll do, got to get a common denominator here. So I'm going to multiply this one by x minus 1. I'm going to multiply this one by x. And I'm going to multiply this last one by x and x minus 1. So I got to multiply it by x, and I got to multiply it by x minus 1. So then what that's going to look like is 40 times x minus 1 minus 42 times x plus 4 times x minus 1. And that's going to be all over our common denominator of x times x minus 1. So I'll go ahead and distribute here. So I get 40x minus 40 minus 42x. And then over here, I would go ahead and distribute that together. And so then that's going to give me plus 4x squared minus 4x. That's all over x times x minus 1, and then that's actually all combined like terms first. So combined like terms now, we have 4x squared. Let's see, we got negative 46 and positive 40x. That makes negative 6x. And then minus 40 over x times x minus 1 equals 0 over 1. And so now we'll cross multiply. Now you'll notice that that actually gets zeroed out. So that will become 0 equals, and then this times 1 is obviously going to stay the same. And so 0 equals 4x squared minus 6x minus 40. So now we're going to factor that. So I'll GCF a 2 first. It's going to leave me with 2x squared minus 3x minus 20. And then we'll do a little diamond here, negative 40 and negative 3, which sounds like negative 8 and 5. I do have to do my grouping here, negative 8x and positive 5x minus 20. And then we'll group this up and that. So I'll take out 2x, which leaves me with x minus 4, and plus 5, which leaves me with x minus 4. So I'm out of space, so I'm going to go over here. So I got 2x plus 5 times x minus 4 equals 0. So x must equal negative 5 over 2, and then x must equal 4. And I check those, make sure it doesn't make any of these denominators in the original question 0, which they don't, so those are both legit answers. All right, next up here, we got a radical equation. So already I'm worried about extraneous solutions, so let's just keep that in mind. To solve it here, I'm going to subtract the 2x over. And then so we get rad x plus 23 equals negative 2x plus 9. And so we'll square both sides. And so I get x plus 23 equals, and of course this will be a FOIL here. So this will be 4x squared, negative 18, and negative 18 makes negative 36x plus 81. I'm going to get one side to 0 now. So we get 4x squared minus 37x. This would be 58. Okay. So we'll do a little diamond action now. So 58 negative, oh, not 58, excuse me. So we have to do a times c up top. So 58 times 4, which is 232, and negative 37. So let's break down 232. It's even, so we can divide it by 2 times 116. So obviously that's not going to work. Let's try 4. 4 and 58 still won't work, but I'd say we're getting closer here. I know it doesn't divide by 3, so I don't think 8 works. Oh, 8 does work. 8 and 29, and actually, those are our numbers. Okay, so now we need to use our grouping. So 4x squared minus 29x minus 8x plus 58. And so we can group these up. The first group I can just take out an x, which would leave 4x minus 29, and the second group I can only take out a negative 2, which would leave me with 4x minus 29 as well. So I get x minus 2 times 4x minus 29. So I mean x equals 2 and x equals 29 over 4. Now we do need to check these for extraneous solutions. So I know that 29 over 4 is going to suck, but let's try 2 first then. So 2 times 2 plus the square root of 2 plus 23. I'm plugging this back into the original equation. So 4 plus rad 25 equals 9, and that does check out because it's 4 plus 25. And then the other one, 2 times 29 over 4 plus the square root of 29 over 4 plus 23 equals 9. And you know what? I'm just going to do this left side in a calculator on this one. I don't think that's worth your time to calculate that by hand, so let's go for it here. So that turns into 20 equals 9, which is obviously not true, and so I'm going to say that this is extraneous, and that one is correct. So there you go. Don't assume that just because that one was a fraction, that is not why it was extraneous, so let's not make that conclusion. It's just that it didn't work out. Sometimes you might have the same problem, and the fraction works and the integer does not, so you just got to check them. All right, next up here we got number 21, so this is absolute value equation. So we need to isolate the absolute value and then split it into 2. So I would add 1 first, so I'll just kind of, I'm not going to show my work for that. All right, yeah, sure, why not? All right, there we go. So they'll cancel out over there, and that'll equal 2. Then we divide the 2 over to isolate the absolute value, and that equals 1. And now we're going to split it up. Now, at the point that I'm splitting it up, if I'm equal to a number, there's actually going to be no extraneous solutions. I do not even need to check. But just remember, if you're not sure on these ones, you can always check. It's never going to be wrong to check. But this one, technically, I don't need to. So 5x plus 10 equals 1. And then on the second one, I change what's outside. No matter what's inside, even if there's a negative inside, which there's not in this case, but even if there was, just change what's outside, okay? So then I'll solve each of these. So 5x equals negative 9. And then x equals negative 9 over 5. And then on this one, 5x equals negative 11. So x equals negative 11 over 5. Great. All right, next up here we got this set. And so all these are dealing with kind of solving fractional exponents. And the big kind of point I wanted to get across on these ones is that we only need the plus or minus if we create an even root. So we're going to be doing some even roots and some odd roots here. So the thing is, the even roots are going to require a plus or minus, and the odd roots are not. And we'll kind of talk about why as we go along here. So for the first one here, I would just, since I kind of got it down to this level, and there's no factoring before this. Factoring, I prefer the fractional exponents, but now at this point, you can kind of think of it as the third root of x and then to the 5th power, and that's going to equal 243. So then to get rid of the 5th power, I would do the 5th root. And so the 5th root of 243 is 3. And so I'm going to say the cube root of x equals 3. And I'm not going to do a plus or minus there once again, because we're only going to do that if we have an even root. So this one's an odd root, so I'm not going to do that. So then next step is to get rid of the cube root by raising this to the 3rd power. And so that's going to mean that x just equals 27. Now, next question here. We have the cube root of x to the 4th power equals 625. And so now I'm going to take a 4th root here to get rid of that 4th power first. Now this one, since it's an even root, I do need the plus or minus. So it's going to be plus or minus 5 equals the cube root of x. And then we will raise that to the 3rd power. Oops. and the third power is going to keep the negative 1 negative and the positive 1 positive. So for me, that's going to be negative 125 and 125. All right, next up, question C. I'm going to visualize that as the cube root of x squared equals negative 36. And so I'm going to start off by doing the square root to get rid of the squared there. But right away, I see I have a negative inside of a square root. And this is saying if the answer is not a real number, so it doesn't want any imaginary numbers. And so I can see right away that this is it's plus or minus 6i right here. But I'm going to put not real since that was kind of the instructions here. All right, next up on question D, for this one, I'm going to visualize it as the fourth root of 64 and then to the third power. Oh, no, I'm not going to do that at all. The fourth root of x to the third power, and that's equal to 64. Okay, so then we're going to do the third root here. And that'll be the fourth root of x equals, and over here, since we're doing an odd root, we are not going to do a plus or minus. And so I'm going to get 4 here, so just 4. So then I'm going to raise this to the fourth power, and that's going to give me 256. All right, next up here, we're trying to isolate k, but it looks like I have two k's that are kind of in unlike terms. So remember, whenever we do this, we want to get everything with a k on one side. And so I'm going to add the tk over to this side. And I'm going to subtract the L over to the other side. So I'm going to get everything with a k, the thing I'm trying to isolate on one side, and I'm going to get everything without a k on the other side. And then my next step is always to factor. So I'm going to GCF the k. That'll give me f plus t inside, and then I can just divide that over, and I'm done. Sloppy writing here, so we'll try to write that neater. Oh, that's a t. All right. Got a little too excited there. I isolated the k. Boom, boom. There we go. All right, next up here, we're solving this equation. This is quadratic form because you can see that this power is half of that power. So I can use a diamond here. So I'm going to do a times c up top. Need a calculator for that. So 6 times 26. Negative 156 and 35 there. So we'll break down 156. Let's see what we got here. So obviously it's even, so we can use 2. 156 divided by 2 is 78. So that's obviously not it. Divided by 3 is 52. Not it either, but I actually think I'm getting close here. So let's try 4. 4 is 39, and that is it. So we got a positive 39 and a negative 4. So now, since we got that 6 out front, we do need to do our grouping here. So I'm going to say 6w plus, I'll do minus 4w to the 1/2 plus 39w to the 1/2, and then minus 26. So remember that I attach these here to the 1/2 power in this case because it's representing us splitting up that middle term in this technique. So then I'm going to do my grouping. So the first group, I can take out 2w to the 1/2, and that leaves me with w to the 1/2. Actually, it leaves me with 3w to the 1/2 minus 2. And then the second group, I can take out a positive 3, which would leave me with, oh no, not a positive 3, excuse me. Positive 13, which would leave me with 3w to the 1/2 minus 2 as well. So I have 2w to the 1/2 plus 13, and then 3w to the 1/2 minus 2 equal to 0. And so now I can split those up and set them equal to 0 individually and solve. So 2w to the 1/2 plus 13 equals 0, and then 3w to the 1/2 minus 2 equals 0. And so this would mean that w to the 1/2 equals negative 13 over 2. And then this one would mean that w to the 1/2 equals 2 over 3. For this one, I'm going to kind of visualize this as a radical here, since that's what the 1/2 power is. So I'm saying the square root of w equals negative 13 over 2. And actually, on that one, I'm actually going to say that this is going to yield us no solution because it's impossible for a radical to come out to a negative. Some of you may be thinking that we need a plus or minus in front of that radical, but we didn't really create that radical. It was actually part of the problem as the 1/2 power. So we only put the plus or minus if we created the radical. So this part is going to yield us no solution. This one, though, the square root of w equals 2/3, that is going to have a solution, which I can find by squaring it. So I'm going to say w equals 4/9. No plus or minus there because I didn't create a square root. I actually created a squared, which is not the same thing, obviously. And so I got this answer of 4/9. Now, I'm not going to type in no solution. I know that piece gave me no solution, but the other piece gave me a solution of 4/9, so I'm going to list that one.